All right, we're taking a look at another quadratic. And yes, this is a quadratic, but it's just not as pretty as the last one. Well, rely on your old PSA skills. Don't give those up. Those are really, really valuable skills to have. So there's 6 and 5. If we do all the factoring, we'll find this out to be 2 and 3. So of course, x plus 2, x plus 3, and away we go. Now, we want to find the critical points, of course, that are on this nice little x-axis. That x-axis means the y equals to 0. Now we can solve this. When we solve this, x, of course, equals to minus 2, and minus 3. Those are our two critical points. Or when you're doing a parabola, we know them as our zeros, our solutions, our x-intercepts, and so on and so on and so on. Okay, so we know at minus 2 and minus 3, we have a point. But since this grid is so small, I'm going to just skip a point here and call these, we're going to just gap them a little bit wider here. Okay, so this will be our minus 2 right here. This will be our minus 3 right next to it right here. So we know that this particular graph is going to do something like this. It's going to come down this way somehow, like that, okay? Hit this 3, come back up this way. But I want it to be fairly accurate, okay? I want to know, well, let's find out where it cuts this axis, which of course we know is the y-intercept. Y-intercept is when x equals to 0. Ah, so this becomes no longer this ugly thing here. It actually becomes really easy to graph. We substitute in x equals to 0, get rid of that guy because 0 squared is 0. 5 times 0 is gone, and look at that. There's our y-intercept. So with our y-intercept being there, let's go out and just do the same kind of grid that we did on the other side, same kind of increments, skipping 1, skipping 1, skipping 1, skipping 1, and then of course it's going to be way out here. So 1, 2, 3, 4, 5, and finally 6 is going to be out here. So we know that this is going to come down like this, hit here, and we know that this is going to come out and do something like this. There's our parabola, and we know with a parabola, it should somehow scoop down here like this. Well, I don't know how far it's going to scoop down. So that's where I'm going to start using the technology. Let's bring in this technology aspect of it. Well, I can't read this very well because I scribbled all over it. Ah, there we go. Let's go back and start using the technology. So of course, we want the absolute value. So y equals to, find the absolute value by hitting math, mouse over to number. There's the absolute value. And again, depends on what kind of calculator you have. It could come up ABS, which stands for absolute value, or the absolute value symbols, whatever. Okay, x squared plus 5x plus 6, close the bracket. Let's graph this thing. There's the graph of it now. Well, the way it's graphed, if you look in here, it looks like it's just touching the graph when one section comes down here, touches, then comes back up. But we know better because an absolute value function should somehow bounce up like this and give us something like that. So obviously, we can't see that very well. So how do we do it? Well, bring this back, and I'm going to show you one of the most powerful things on your calculator. Hit zoom. Look at the first thing. It says zoom box. What does that mean? Well, hit enter. What I'm going to do is I'm going to draw a nice little box around the area that I can't see so it can magnify it a little. Now, you're probably saying, how am I going to go about doing that? Take a look at this. See this? It says your pointer is at 0, 0 right now. And if you look right there, you can kind of see it blinking a little bit. Well, that's a good thing. Okay, we're going to take that pointer and we're going to move it around with our little cursor here. And you can see that I'm going to bring it out here. And now it's made a little cross with a little dot in it. Okay, so I'm going to just put it right about there. And that's going to be our corner of our box, right about there. There's the corner of our box. So let's plant that corner right there by hitting enter. Now, look how the cursor changed to a square now with a white dot in it. Well, watch this. It's kind of neat because as soon as you start hitting this and move it over and you're building the side of the box, and even if you went too far, you can always go back, that's the side edge of the box. Now, don't hit enter, just mouse up. Look at that. Look at this. There's my box. I'm going to zoom in on that section of the graph. And when I do, watch this. This is really pretty. Watch this. Now we can see the bump. Awesome. Absolutely awesome. So we know, in fact, that this doesn't just touch in one spot. It touches in two spots, and we can find how high up this bump is. Oh, fantastic. Well, how do we find out what that bump is? Well, if you take a look at this, isn't this an arc here that looks a little bit like the parabolas that we used to do? Isn't this arc facing downwards? So wouldn't that point be some kind of maximum? Aha, I just gave it away. Hit second, calc, find the maximum, which is 4. There we go. Left side, left bound, hit enter, mouse over. There it is, right bound, hit enter again. Of course, it asks you to guess, and check it out. It's exactly at minus 2.5 and 0.25. So in other words, this thing is right here at minus 2.5, right smack in the center, minus 2.5. And, oh, what was that value again? 0.25. So this thing only goes up a little bit like this, and I actually drew it too much. That's about accurate, right about there. Holy smokes, isn't that kind of cool? So now you've got a really, really accurate graph. So what we can do is we could do it that way, or, yep, this is the way we did it before. We could also complete the square. Oh my goodness, if we're completing the square in this, look how ugly this becomes. Here we go. We could find that vertex. We know it's minus 2.5, right? And a quarter, which is 0.25. Okay, so let's do this by completing the square method. Here we go. Well, we have x squared plus 5x. Okay, complete the square, meaning you have to put the 6 out here, right? Half of this is, of course, 5 over 2. There's your magic number, okay? Right? We square it to give you plus 25 over 4 here, which means you have to subtract 25 over 4 here, all right? Then this gives you x plus 5 over 2 squared. Now, you're subtracting 25 over 4. That has to be common denominator, which means this is 24 over 4 minus 25 over 4 gives you, check it out, minus a quarter. Look at that. Beautiful. Awesome. So if you look at that, then you know your vertex, then if it was a parabola would be at minus 5 over 2, comma, minus a quarter. But don't forget, let's go back to our nice little graph here. That was for a parabola. That means the parabola would have to come down this way, like this, and circle up. And that would be that point of minus 2.5, right? And minus a quarter, 0.25, right? Well, don't forget that we're doing the absolute value of it. So that's why it's right there. That's why this is no longer a negative, but it is a positive. Awesome. Boy, this is really cool stuff. Now, the last thing we have to do for this thing, of course, is, guess what? Yep, you guessed it, piecewise. So let's do the piecewise function for this. Let's get rid of all of this stuff here, and let's make it really nice and pretty. We know we're here. We know we're here. Perfect. Down we go, out we go. Now, remember what that point was. That was at minus 3. That was at minus 2. All right. Then we had our nice little bump that went out this way. Perfect. So let's do this for the positive value. The original function was this. Okay, let's do it for the positive value. So this is x squared plus 5x plus 6 for the positive value means what? You were looking at what part of the graph? You were looking at the positive part of the graph, the original parabola. So the original parabola at minus 3 that way, at minus 2 that way. So x has to be, of course, less than or equal to minus 3, and x has to be greater than or equal to minus 2. Now, look for the negative part. That was the parabola here, right? Right there, I'll put it in another color. This part of the parabola, that was flipped. We flip it by making it a negative. X squared plus 5x plus 6. And of course, we're looking at just a small little section in here, this corner right here, just this little section. So that means that x is between negative 3 and negative 2, greater than negative 3, less than negative 2, and we solved it.